Hello class, welcome to this video on the 7.3 practice problems. This lesson on on chapter 7, lesson 3 is on proving two triangles similar. So there's going to be a lot of questions where we determine are two triangles similar and similar types of questions, as well as solving for some unknown sides. So let's go ahead and get started. Now question 1, you may need to make a correction because on the quiz you may have an old version of the quiz, and if you do, just keep in mind that the 35 degrees was not labeled on the diagram, and this is to give you an idea of which sides go to where. Okay, so now that we got the hint here, and it says hint here, use three sides. So we're going to use the three sides to determine if these two triangles are similar. Now, if you look at the 35 degree side and you look at the side directly opposite of that, that will help identify which two sides correspond to each other. So in this case, it seems to be that LM corresponds to JH. And so this is why I wanted to provide the angle as a reference point. So we can take 7.1 and divide it by 2.84. And then we're going to see what that is in a little bit. But what we want to do is that number, when we divide those two numbers, should match up when we divide two other sides in the triangle. So another set of sides that correspond you can use as a reference point is, well, we know this angle, which is G, which is 35 degrees. The side that is next to it, that is the longer side of these two sides here, the longer side is 3.6. Well, that corresponds to the longer side for the 35 degree angle for K here. And so we can kind of tell that LK corresponds to GH here. And so we know that 9 corresponds to 3.6. So we can divide those two. And those two fractions should equal each other. And if they don't, that means that they're not similar. We're going to test out one more here. Finally, we have the two remaining sides. So we have 5.6 divided by 2.24. And we'll test to see if these numbers provide the same scale factor. If they do, then the two triangles are similar by SSS similarity. So let's divide the separate fractions here. So we got 2.5 for the first fraction. We have 2.5 for the third fraction. And we have 2.5 for the third fraction. And therefore, these are all equal to the same scale factor. And therefore, the two triangles here are similar by SSS. Now, they could also be similar by SAS because we proved that two sides corresponding sides are good, and then we have the angle in between. But in the hint, it says use the three sides, so we are only going to be using SSS here because it wants us to use the three sides for the hint, okay? But keep in mind that this is also technically true by SAS. It's also similar. All right, so for question 2, it says, are the two triangles similar? If so, state which theorem shows that the two are similar. So we know that these two sides are congruent, and we don't know what they are, but we do know that they're congruent. So there's a couple of ways that you can actually, a couple of things that you can do to think about this. Because we know these two sides are congruent, then that means that these two angles are congruent. And if those two angles are congruent, then that means that we have an isosceles triangle, first off, because we have two sides that are the same. And we can figure out what those angles are, and we can compare them to these angles here. Now, because these are isosceles triangles, and this is 34 and this is 34, that means these other two angles are going to be the same. But let's go ahead and find them anyways. So we do 180 minus 34, and that's going to be 146. And then we divide that by 2 so that we can get both angles here, each of them. And that's going to be 73 degrees. So each of these is 73 degrees. So the point that we want to establish is that, yes, these are similar, and you can clearly tell from the angles, okay? However, just to answer the question here, given this information, we could show that these two triangles, so just looking at this information here and not showing anything, we can show that these that these two sides are the same and then these two sides are the same. And so these are proportional to one another. So this is going to be a side angle and a side angle and a side. And here's sort of like the proof, I guess you can say. We kind of proved it with the angles here. But yeah, these two triangles are similar by SAS because of the side angle side here. But let's call this X. And if that's X, then this is X. And let's call this Y and this Y. And so if these are similar, then that means if I take the ratio of X to Y right here, so I take X divided by Y, because clearly, you know, that this side has to do with that side, and then this side has to do with that side. So X over Y is equal to X over Y. And so this is true, right? So because this is true, this means that those two sides are proportional to one another. And also, we know that the angles are congruent, so angle R is congruent to angle C, and therefore we can say automatically that this is congruent by SAS. Even though I kind of proved that you could use angles to do this as well. But we will choose that because that is the more direct question, answer to that question. So question 3, find the value of the variables A and B such that the triangles are congruent. So if you look at this, these triangles, you can see that these two angles are congruent because of vertical angles. Those are vertical. So vertical angles are always congruent. So that's one thing that you want to remember. And we can kind of see based off of this image here on this triangle on the left that it's sort of an inverted or reflected position of the triangle on the right. So if I flip this and I get something like this, and then I flip that again, then I'm going to get something like this. And so then you can see that this 94 degrees right here, which flipped to this side and then flips over here, this is the same as my A. So we can kind of tell from the diagram that A is actually equal to 94 degrees. So those two triangles are congruent. And you can see that with the transformation that I do. If I do a similarity transformation, then that works out. So we know that the angles are the same there. So I'm going to go ahead and say that this is 94. Those are equal. Let's do two arcs there. And so because we know those are equal, we can use those as guiding points for my other sides. So we have here 20 corresponds to 35 in this diagram, because you can see this 20 is between these two marks that I made. There's 35 is between those two marks that I made. If you do the transformation, you'll be able to see that as well. So 20 is to 35 as, in this case, if you look at 21 is beside the angle here, and so is B. So B is to 21. And you can use this to solve for B. So let's cross multiply. We got 35B equals 420. Divide by 35 on both sides. So we'll do 420 divided by 35 here. And you get 12. So B is equal to 12. And we just said that A was equal to 94 by using those transformations. We were able to tell that. All right, so that takes care of that question. For the next one, when Esteban looks at the puddle, he sees a reflection at the top of the palm tree. How tall is the palm tree? So we have two triangles. You can tell that this is a triangle. It's a right triangle, and then so is this. This is another triangle. So if we call this height X, well, we can clearly see that this X, this side corresponds to this side on this triangle. So let's draw this triangle here. It corresponds to this side on the triangle. So X corresponds to 1.5 as, in this case, 10 corresponds to 2.5. And then we can use this to solve. We'll cross multiply. So we got 2.5x equals 15. We'll divide by 2.5 on both sides. And so x is equal to 6. All right, so the palm tree is 6 meters tall. All right, so looking at the next question, are the two triangles similar? If so, state which theorem shows that the two are similar. So we have 3 sides, so we're probably going to use side, 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 but we got to determine which side goes where. Okay, so if I were to do a transformation to be able to convert this to that, a similarity transformation. Remember, a similarity transformation is when you convert one figure to its similar figure. So we can get these to overlap here. So this point right here, I'm interested in taking that point and moving it here and then rotating it. So if I were to rotate this way, then I will get a figure, and then I translate it, then I'll get something that looks like this, right? And then this is A, and then right here, that's going to be my B in that case. Well, it's not going to be all the way over there because this is a smaller triangle. It's going to be more like over here or something. And then this is going to be my C, right? So if I take that and I rotate it and I move it, I'll get something like that. And we can clearly see that the 3.8 side right here corresponds to the 5.4 right here. Okay, so 5.4 corresponds to 3.8, so we can find the scale factor there, equals, and then we can see that 6 corresponds to the 9 here. So 9 divided by 6. And then finally, we can see that the 7.5 side corresponds to the 11.25, so we'll divide those. Now, if any of these numbers are not equal to the other, the fractions are not equal, then that means that the similarity relationship is broken. So these are not going to be similar. So we have, for the first fraction, 1.42, the second fraction, 1.5, and the third fraction, we have 1.5. So we can see that 2 of them are equal to 1.5, but the third one is not equal to 1.5, which is why you want to verify this. Even though these checked out, this did not. So that means that these two triangles are not similar at all. All right, so hopefully that made sense. For the next question, we're going to do the same thing with the theorem. So are they similar? So if this is 60 and this is 40, well, then we know that this has to be 80 degrees because the angles have to add up to 180. And if we add those together, we get 180. Similarly, this has to be 40 because they all add up to 180. So we know the angles in the triangle. And we can clearly see that we have 2 angles that are congruent. One here, this and this. And of course we have 3, but we only need 2 to be able to determine if they're similar. So we clearly have 2 angles similar, so we can say that these 2 triangles are similar by angle. And just going back to this problem right here, or going back to this problem, let's go ahead and write the similarity statement for these 2 triangles, because we did find, or for these triangles here, we did find that they're similar. So let's write the similarity statement. So the similarity statement here is, we know that so let's do JKL, and that is similar to triangle. Now J corresponds to the P side, because that's the 60-degree side, angle rather. And then K corresponds to Q, and then L corresponds to the 40-degree angle R. And so that's going to be the similarity statement. JKL is similar to triangle PQR. Okay, going to the next question, are these similar? We know that this is 22, that's 50, so 50 plus 22 is 72 degrees. And we know that 72 plus 108 is equal to 180, and so therefore this has to be 108. And we clearly see that those 2 angles are congruent, so that's good. We can also determine, let's look at the sides here. So if I were to look at this side clearly corresponds to this side right here. So let's divide those 4 divided by 3. And then let's look at the next pair of corresponding sides. 6 corresponds to 8. So we have 8 divided by 6. And so let's go ahead and see if those are the same fraction. And in fact, they are the same fraction, because if you divide this by 2, you're going to get 4/3. So this checks out. These are the same number. Therefore, since you got 2 sides that work here, and you got an angle that works in between them, these 2 triangles are similar by SAS. So this is true. And therefore, the similarity statement is triangle STU is similar to triangle, in this case, X, angle T corresponds to angle Y, and X corresponds to S, and so these 2 are similar. For the next problem, we want to determine FJ. So we're going to call that X. So this is going to be X. And it says that triangle FGJ is similar to triangle FHG. So in order to determine X, we know that, let's color code this. This is FJ on the smaller triangle, which corresponds to FG on the larger triangle. So these two sides correspond to each other. So X is to 15 as, and then for the side 15, we know that 15 right here, this 15, which is the 15 for the larger triangle, or rather for the smaller triangle. This is the smaller triangle that I'm referring to. The 15 for the smaller triangle, which is, and this is FG for the smaller, that corresponds to FH in the bigger triangle. And FH in the bigger triangle is this one right here. And FH is actually X plus 16, because you had to combine these 2 sides together. So the equation is X is to 15 as 15 is to X plus 6. Then we can cross multiply. We got X times X plus 6 equals 225. We'll distribute. Okay, so now this is a quadratic equation. In order to solve this, we need to make this one side equal to 0. So we're going to subtract that off and put everything on one side. Next, you want to set up what I call an X box or an X table. And you want to figure out the numbers that multiply to negative 225, that multiply to it, but that add up to 6. So it's always, the top number is always the constant. The bottom number here is always the coefficient of the x, not the x squared, but the x. So 2 numbers that multiply to 225, and you can do this in various ways. So let's, for example, you can use a calculator and divide numbers. So 225 divided by 5 is 45. There's no way that you can get 6 from 5 and 45. So 225 divided by 25 is 9. So 25 and 9, there's no way that you can get 6 from 25 and 9. So if you look at, oh, this is actually a 16 rather. I wrote the wrong number here. This is a 16, not a 6. So this is actually 16x. So in fact, this actually does work. So 25, and let's use another color here. This actually does work. It's possible for you to add these to get positive 6, because you need to make one of these negative, because you want to multiply to get negative 225, and so therefore 9 has to be negative. So if I multiply these 2 numbers, I get negative 225, but then if I add them, 25 plus negative 9 is 16 rather, not 6. So this should be a 16, because that's a 16 right here. And so therefore we solved the puzzle. We can use these two numbers. So what we do now is we factor this trinomial. This is what we call a trinomial, 3 terms. We'll factor it like this. And what we want to do is, well, we know that this is going to be x because x times x is x squared. And then these two numbers that we found go next. And we know that 25 times 9 is 225. And then if you FOIL this or distribute, you're going to get the top. So the next thing, you want to determine what makes each of these equal to 0. So we're going to solve each of those. So x plus 25 is 0. X minus 9 is 0. So the only thing that makes x plus 25 0 is x is negative 25. For the right side, x would have to be 9. So we solved this equation. We have 2 solutions. However, notice that this solution doesn't make any sense because it's a negative number and we're talking about these sides in a triangle, so it doesn't make sense for it to be negative. So we're going to cross this solution out and we'll just say that x is equal to 9. So therefore the final solution is that fj, which is equal to x, is 9. All right, so let's look at the final question here. So what condition is sufficient to show that the 2 triangles are similar? And select all that apply. All right, so it says RP is 4.5. So right here, this is 4.5. That's what it says there. So we want to see if that's sufficient. Well, if we know that RP is 4.5, then we can show by SSS that they're in this case that they're similar if we find this out. So we know that this side looks like it corresponds to this side. So 6 divided by 3 is 2. And then we can see that 10 divided by 5 is 2, and then 9 divided by 4.5 is 2. So we could definitely use this in order to determine that they're similar. So therefore we'll check that answer. And let's look at the next one. The next one is that angle Q is 63. So they're saying that this is 63. Are we going to need that? Well, if we had that, let me erase the 4.5 now and just start fresh. So then if we have that, well, okay, then that means that we have this angle is congruent to that angle, which that's good. And then we have that 10 corresponds to 5. So 10 divided by 5 is 2. And then 6 corresponds to 3. 6 divided by 3 is 2. And so we have side, angle, side, side, angle, side. So we can show that they're similar by side, angle, side. So that's true. All right, and then if angle P is 81, angle P right here, if that's 81 degrees, okay, so looking at if they just gave us this information, 81 degrees, and then these two sides, this is not going to be enough information to show that they're actually similar, because we have an angle, we have a side, we have another side, and remember the 3 theorems that we showed that can be used to help us determine that two triangles are similar are AA similarity, SAS, and SSS. And there were no other theorems that we discussed that will allow us to determine if they're similar. So there's a couple things wrong with this. First off, P is not equal to 81, and 2, you can't use a theorem to help us determine this. The reason why P is not equal to 81 is because if these two triangles are reflections of each other. If you reflect it here, then you're going to get R, or you're going to get R being here, and then Q here, and then you're going to get P here. And so you can clearly see that R is 81, but not P. But that's not solely the reason why. The main reason why is we don't have enough information to determine. Okay, so it's definitely not going to be C. R is 81. Well, we mentioned that R is 81 if we use a reflection. However, if R is 81, that really doesn't give us any information to help us determine a dissimilar, because we don't know what this side is at this point in time. Like, we knew that it was 4.5 for part A, but we no longer know that information for part D. So there's no theorem that we can use for if we have that angle. Now, so that can't be it. Now for the last one, RP is equal to 4. You see how they switch it now. If RP is equal to 4, well then that's not going to work anymore, because 3 times 2 is 6, but 4 times 2 is 8, and we don't have 8 on that side, we have 9. So that would not be true. And therefore the only answers are A and B. Alright guys, that's going to do it for the video. I hope you found this informative. I hope you found this useful. And as usual, I'll see you in the next one.